So today I want to talk about a technique called completing the square. And this is a technique for solving what are called quadratic equations. And to motivate that, I want to look first at a simpler kind of equation. So let's take an example, say 7x minus 2 equals 2x plus 4. This is known as a linear equation, and the technique for solving an equation like this is isolating the variable. So here we'll go 7x minus 2x equals 5x, whereas 4 plus 2 equals 6. So I've subtracted 2x and added 2 to both sides to keep this an equation, and now I get x equals 6 over 5, my solution. Now a quadratic equation differs from a linear equation in that you find something like the variable x being squared. So you might see something like 2x squared minus 4 equals 7. Here's an example of a quadratic equation. Now in this particular kind of equation, this particular quadratic equation here, we can also work by isolating the variable. We can get 2x squared equals 11 by adding 4 to both sides. So x squared equals 11 divided by 2. And now we've almost isolated the variable. Since x squared equals 11 over 2, we get that x equals the square root of 11 over 2 with a plus or minus in front. I have to put the plus or minus because whenever you take the square root of something, like for example, the square root of 4 is 2, because 2 times 2 equals 4, but it's also negative 2, because negative 2 times negative 2 equals 4. So I always have to have the plus or minus. So we see in this case, even though things were a little bit more complicated because we have a square root thing going on and a plus or minus, still we were able to isolate x and solve the equation. But a general quadratic equation might not be so easy. So let's take another example, say x squared minus 2 equals 6x plus 3. Also a quadratic equation, but the difference here is that the x variable occurs both squared and not squared. So how do I isolate for x? Right? I can rewrite this as x squared minus 6x minus 5 equals 0. And I can move the 5 over here by adding it to both sides, but I still have x in 2 places. The question is, how do I isolate for that? Okay, and so completing the square is a technique, a very useful technique actually. It's the technique that can be seen to underlie the quadratic formula, which is something I'll probably do another video on. But completing the square works like this. First I look at the first part of this. I see x squared minus 6x. And I think, okay, I can get that in a different kind of way. I can write x minus 3 squared to get this first part. What do I mean by that? I mean, I took 6, negative 6, and I divided it by 2. And now if I work this out, I get x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9. So I got the first part. I got x squared minus 6x just by taking this and dividing it by 2 and then squaring it like that. But I also got this pesky plus 9, which is not what I wanted. I wanted a minus 5. But when it comes to equations, changing plus 9 into minus 5 is very easy. Because this equation holds, it follows, therefore, that if I do x minus 3 squared, and I don't want plus 9, I want minus 5, so if I just subtract 14 from this, then I should get x squared minus 6x plus 9 minus 14, which is exactly x squared minus 6x minus 5. In other words, this thing that I wanted. Which means that x squared minus 6x minus 5 equals 0 is the same thing as saying x minus 3 squared minus 14 equals 0, which is the same thing as saying x minus 3 squared equals 14, and that tells me my final answer, x equals 3 plus or minus the square root of 14. So I've isolated for x.